I'm here at Town Centre Park in Coquitlam, British Columbia, where a new construction project has begun, replacing a section of the city's water mains to meet the region's growing demand for drinking water.
This new water main will span 12 kilometers and is split into 4 sections. The project is set to be complete by 2030. This is the first of 4 sections where hundreds of trees have been removed along this stretch to make way for the digging of a deep water main trench.
You'll rarely see a construction site without one or more excavators. This site currently houses several, which are used for excavation, demolition, leveling, landscaping, and lifting. On a site like this, excavators account for a significant portion of greenhouse gas emissions.
Unfortunately, low-emission machinery is difficult to come across in Vancouver. Besides a few hybrid excavators which are more focused on performance than emissions, there are no currently used low-emission solutions implemented in Vancouver at this time.
Our goal is to reduce emissions by electrifying these machines, which are crucial to construction across Metro Vancouver and beyond.
To ensure our solution satisfied the many varied perspectives represented on a project of this scale, we conducted extensive engagement with a wide variety of stakeholders. We focused on groups closest to the project, including excavator operators, construction companies, the residents of Coquitlam, and regulatory bodies, such as the Vancouver Air Quality Association and the City of Coquitlam. By engaging with our key stakeholders through interviews, surveys, and research, we identified their needs. Key considerations that influence our design decisions were ease of transition, emissions reduction, operating time, annual worth, safety, and power output.
We began concept generation by looking at the individual operating elements. We considered power sources such as direct grid power, hybrid power, hydrogen fuel cell, and hydropower. We selected an appropriate electric motor based on power requirements and considered several battery types to meet the operating time, peak motor power draw, and cycle life requirements.
We narrowed down our concepts to using grid power with a 250 horsepower motor and a lithium-ion battery. Then we generated concepts that incorporated these elements. We eventually came down to 2 options. First is the built-in excavator battery with plug-in charging, and the second option features swappable excavator batteries with a battery charging station. Through a cost-benefit analysis and consultation with our stakeholders, our final solution was then chosen to be an electric excavator with a built-in battery that possesses grid power charging capability.
To maximize the cycle life of the battery, we will use a battery that will be charged up to 80% and discharged to 20%, offering an 8-hour operating time. The 250 horsepower motor meets the power requirements for the Coquitlam water main site, and necessary charging infrastructure is available through BC Hydro with power line connections.
Our solution offers a fully electric alternative to mid-size excavators like this John Deere 380G. By replacing the diesel engine with an AC electric motor and incorporating a lithium-ion battery pack, we'll be able to extract similar levels of performance while completely eliminating the need for diesel fuel.
Our recommendation also includes the implementation of charging points along the construction route. These will be directly connected to the grid through transformers such as this one, and draw enough power to fully charge the excavator outside of working hours.
The elimination of the diesel engine not only removes the majority of emissions associated with burning fuel, but also grants reimbursements from the government. Taking into account all the costs and benefits, our solution costs $30,000 less per year when compared to the current diesel excavator. Moreover, we predict our solution will possess a similar lifespan to existing excavators, and the cost for implementation expansion to other sites will be consistent with the annual cost of the solution for our particular pilot site.
We recommend that as an additional provision, the VAQA be prepared to subsidize electricity costs for construction companies employing our solution. Ensuring an economic benefit is key to incentivizing a broad implementation of the new technology.
Looking into the future, pending successful feedback from our pilot implementation site and a gradual rollout to other companies and sites, we can expect more companies to start turning to electric excavators if our recommendation is followed. The shift would be due to seeing the work and operational cost benefits that the excavator itself brings, and also the potential financial benefits from regulatory bodies like VAQA. This would in turn lead these companies to think about electrifying other aspects of their fleet as well, further reducing carbon emissions. There will be more interest in electric excavators, leading to more research and development into improving the technology in terms of efficiency, cost effectiveness, and other aspects. If our recommendation is not followed, there will be a weaker push to develop better electrification technologies for excavators, and excavators will continue to be a notable source of carbon emissions.